Right, good day to all my wonderful online viewers. Just to remind you, if this is your first time of watching this YouTube channel and you have not subscribed, it won't cost you money. Just press the subscribe button, strike the bell also for notification of other videos, and other videos when they come on board you'll be able to see them. Thank you for viewing. Let's continue watching this video. Aspect of chemistry that we have today. Origin of hard water. Hard water is formed when rain falls and it mixes with gypsum. Gypsum is CaSO4.H2O, or limestone. Limestone is CaCO3. Gypsum is sparingly soluble in water, while limestone is not. Now, origin of hard water continues. Only water which contains carbon 4 oxide is capable of dissolving small quantity of limestone. View it very well. Look at it. Only water that contains some quantity of carbon 4 oxide, CO2, is capable of dissolving calcium triisocarbonate 4 to an extent. Look at it, this is calcium triisocarbonate 4, CaCO3 plus CO2 plus H2O go to CaHCO3. This is calcium hydrogen triisocarbonate 4. There are two types of hard water, which include, number one, temporary hard water and permanent hard water. What are the two forms of hard water? Number one, temporary hard water. Number two, permanent hard water. Now, temporary hard water, this can be removed by heating, by boiling, or by decomposing the salt that makes it hard. And what salt can be in water that will make it temporarily hard? One of the salts is calcium hydrogen triisocarbonate 4 or magnesium hydrogen triisocarbonate 4. Now, after decomposing it, one could filter out the calcium triisocarbonate 4 and the other ones will be used. Look at how the equation looks like. Calcium triisocarbonate 4, there is heat here, you have to heat it. This is inside water already. When you heat it, gives us calcium triisocarbonate 4 plus carbon 4 oxide plus H2O. Now, another method of removing temporary hard water is by adding slaked lime. Lime itself is calcium oxide. We call it quick lime. It will become slaked lime when water is added to quick lime. That is when you get calcium hydroxide as slaked lime. And the process of forming slaked lime is called slaking of lime. So, calcium hydrogen triisocarbonate 4 plus slaked lime is now given to us calcium triisocarbonate 4 and water. Let's move on. Now, that is how you can remove hard water. I mean temporarily hard water. Effects of temporary hard water. What are the effects? Number one effect is that it makes kettle and boiler to have fall-like layer, which is due to gradual deposition of calcium hydrogen triisocarbonate 4. Is due to gradual deposition to have fall-like layer. You see something like cement coming up of or staining your ring or your kettle. Now let's do the second one. It also causes stalagmites and stalactites, which are pillars of limestone found in hot caves. Please take note of that. Now, permanent hardness of water. Permanent hardness. This is caused by the presence of calcium or magnesium ion. Permanent hardness can be removed by adding chemicals. We shall be looking at the chemicals in the next video. The chemicals that you add to permanent hard water that will make the hardness to remove. We shall see it in the next, never before. Let us move on to today's work. Water treatment for town supply. This is water, like I told you in the first video. Water treatment for town supply must undergo 4 different processes. If I may ask you a question now, mention the processes through which water treatment for town supply can undergo. You'll be able to tell me that we have coagulation, we have sedimentation, we have filtration, and we have disinfection. Now let us explain them one after the other. First, the untreated water is passed through large septic tank and potash alum. Look at potash alum is KALSO4. The IUPAC name is potassium tetraozoaluminate 3. Can you call that with me? Potassium tetraozoaluminate 3. That's the IUPAC name of potash alum. Or you pass it through sodium aluminate 3. Sodium aluminate 3 is NaAlOH4. Can you say that? Interesting. NaAlOH4. Can you be faster with that? NaAlOH4. That's interesting. Is added for coagulation or flocculation. It's either you coagulate or you flocculate it. But the two major things is just like if you don't use this, you can use the other. That is why it is there. Now let's go on to see. The impurity clumps together to form flux. Flux are impurities. They clump together, they pack themselves together and form flux. Let's go to the next slide and see. The second step is that the water is passed through a filter bed to remove the remaining dirt. It must be filtered, so it will pass through the filter bed to remove the remaining dirt. Now the third step is that the water is treated with chemicals. Number one of those chemicals is chlorine, and chlorine kills germ. Germ could ask you, these are two different words. Germ could ask you, what is the function of chlorine in water treatment? It is to kill germs. Now, other chemicals like iodine and fluorine. Iodine will prevent goiter. Goiter is swelling in the tract in the throat, respiratory tract being swollen and is being protruded out of the outside neck. And fluorine will prevent tooth decay. As you can see, even in the toothpaste you use, read the content, fluorine is there in order to prevent tooth decay. See, you can see my teeth, so you could open your own if it's decaying. Please take precaution. Now the final step is that the water is now free from germs. and stored in reservoir and distributed to the town for use. Hardness of water. Kai, can water ever be said to be hard? Water can be said to be hard if it wastes soap, if it does not foam readily with soap. Take for instance, if kerosene pours on your soap and you are now pouring water on that soap, using it to wash cloth, it will not foam readily. It wastes soap. So, hardness of water takes place when water does not foam readily with soap. Okay, let's move to that slide again. Now see the full content. Those things that are responsible for the hardness of water, there are two major things. They are responsible for the hardness of water. Number one, calcium tetraoxosulfate 6. Number two, magnesium tetraoxosulfate 6. We can also have others. We can have others like calcium hydrogen triisocarbonate 4, magnesium hydrogen triisocarbonate 4. Please take note of this. Calcium hydrogen triisocarbonate 4. Ordinary soap is sodium octadecanoate. I repeat that. Ordinary soap is sodium octadecanoate. Octa is 8. Decanoate is an organic compound with 10 carbon atoms. So this is 8 and 10. That is 18 carbon atom having sodium as the only metal there. When soap is added to add water, the dissolved salt in the water will immediately react with the soap molecules to form calcium or magnesium octadecanoate, which is insoluble. Let us go on. Add water, waste soap. Note, detergents are not affected by hard water. What's the reason? Detergent like your Omo, like Clean, mention all those detergents, they are not affected by hard water. The reason is because they form calcium and magnesium salts, which are soluble in water. Those are the reasons they form calcium and magnesium salts, which are soluble in water. Now we get to go to origin of hard water. What are the origins of hard water? When water dissolves, gypsum. Gypsum is CaSO4.H2O. Or when water dissolves, limestone. Limestone is CaCO3. Gypsum is sparingly soluble in water, while limestone is not soluble in water. So let us go on, and I want to believe you have learned something from today's lesson. You have learned something wonderful. You have learned something great. You have learned those things that can dissolve water, those things that makes water to be hard, and the origin of hardness of water. So keep watching this video. If you have not subscribed to this YouTube channel, please subscribe, because it will be of a very great benefit to you. So God bless your